Chapter 3 is about logic, and logic has rules and a language all of its own. Like other forms of math, what a word means in logic might not be the same as in our everyday lives. The first idea you meet in this section is what a statement is. Here's the definition. That tells us what a statement is, but sometimes it's just as important to know what a statement isn't. So a statement is not a question or a command or an opinion. Now watch out for this last one. If I'd said something like, apples are the greatest snack ever, understand that's just my opinion. It might be true for me, but in general it might not be true or false. As usual, math has to use symbols to stand for statements. Most of the time we use lowercase letters like P, Q, R, S to stand for a statement. And since we're talking about true and false, every statement has a negation, which is just the opposite of the statement when it comes to true or false. There are usually several ways you can negate a statement in English. The math symbolic way is to put a tilde character in front of the statement. So, if P is the statement, it's hot today, then here's how you say, it's not hot today, symbolically. You can express a statement in English in symbolic form, or you can express a symbolic form in English. If you look at example 3, it shows you that. And once again, there are several ways you can translate the symbol into English. Quantified statements contain some words that indicate a quantity, like all or some or none or no. Look at table 3.1. It illustrates some ways of expressing quantified statements. And pay attention to this great question. The negation of all is not none or no. You have to think, what would it take to make the original statement false? And usually you're asking, what's the smallest amount of contradiction it would take? For instance, if I said all M&Ms are green, would you have to say all M&Ms are not green to show me wrong? No. All you'd have to do is show that at least one M&M is not green, and that makes my whole statement false. And if you look at this next great question, it gives you a handy way to remember negations. Wherever you start in this little diagram, the negation is at the opposite end of the arrow. And finally, table 3.3 shows examples of using the great question diagram. Look this stuff over. Let me know if you got questions.